All right, so if we can convert points, then surely we can convert equations. So that's what we're going to be looking at here. So we're going to start going from rectangular to polar. And we're going to talk a little bit with each one about what the picture looks like, right? So first, there's our same picture we've seen a million times, right? We have x is r cosine theta, y is r sine theta. The tangent of theta is y over x. And we know that x squared plus y squared is r squared. So to convert from rectangular to polar, I'm just going to make the replacements. Notice I have the statement here, polar equations start with an r. It's always r equals. So we're going to make the replacement and solve for r. Looking at this first guy, let's just talk about him in the regular Cartesian plane in algebra. This has an x to the first power and a y to the first power, right? So this is just a line, right? It's just a straight line. So now let's do the conversion. I'm going to replace the x with r cosine theta. And I'm going to replace the y with r sine theta. Minus 6 equals 0. My goal is to solve for r, right? So the first thing I'm going to do is move that 6 over. So I'm going to have 3r cosine theta minus 5r sine theta equals 6. Again, I want to solve for r, which is a common factor, right? I have an r in each term, so that means I can factor it out. R times 3 cosine theta minus 5 sine theta is 6. So if I divide both sides by that 3 cosine theta minus 5 sine theta, I will have solved it for r, right? So r equals 6 over 3 cosine theta minus 5 sine theta. Okay? So we're just going to use some algebraic manipulation to get that r by itself. Okay? Looking at the next one here. Can what be done in the calculator? The algebraic manipulation to solve for r? No, you have to solve it for r. Just like you're solving an equation for x or whatever. So on the second guy here, this is like y equals mx plus b, right? It's already in that form. So this would be a line through the origin. And it has a slope of root 3 over 3, right? Just kind of want you to keep that in your head. So the first thing, let's see. A couple things we can do. Let's go ahead and make the replacement. Why don't we do that? So we can say that r sine theta equals root 3 over 3 r cosine theta. Well, look what happens next. I don't want to subtract it because I would have a common r, but then I'm going to have a sine minus a cosine and some stuff is going to be weird. What if we divide both sides by r cosine theta? Well, on the right-hand side, that stuff cancels. And on the left-hand side, the r's cancel, right? And I'm left with the tangent of theta is root 3 over 3. So this one is in here on purpose because it's a little bit different. If we had started from the beginning and divided both sides by x, we would have had y over x is root 3 over 3, correct? And so that is tangent, right? Tangent theta is y over x. So now we got to think about where is the tangent root 3 over 3. Root 3 over 3 is the same thing as 1 over root 3, right? It's just rationalized. So we're looking at it being 1 over root 3. So if that's the case, the y must be 1/2, and the x must be root 3 over 2. And this is true for my family of over 6s. So this is theta equals pi over 6. So we said at the beginning that this was a line through 0, 0 with a slope of root 3 over 3, right? Think about that polar graph. Pi over 6 would be in the first quadrant, right? And I would take that line all the way down into the third quadrant, right, where it would be at 7 pi over 6. Okay. Toodly-doo. All right, so this one looks simple, right? Y equals 6. Let's think about that. So graphically on a Cartesian plane, this is a horizontal line, right, at 6. I'm going to replace the y with r sine theta equals 6. So r is 6 over the sine of theta. Easy enough, right? If only they were all like that. On the next one here, this may or may not be familiar to you, may have been a while. X squared plus y squared plus a 4x is 0. So when I have both the x squared and the y squared, this is a circle. Notice here I also have an x squared plus a y squared, which is r squared, right? So I'm going to rewrite it as r squared plus 4r cosine theta equals 0. Well, we do have an r in both places. But what we're going to do is move the 4r cosine theta to the other side. So r squared equals negative 4r cosine theta. And then I can divide everything through by an r, right? So on the right, my r's cancel, and on the left, my squared cancels. And r is negative 4 cosine theta. We could have taken the r out at the beginning and set it equal to 0, but then you would have had like a r equals 0, and that's weird because that's nothing, right? If r equals 0, think about r as being the radius of a circle. It's nothing, right? Questions?